You already know what a shadow is. You've known since you were 4 years old, standing in the backyard, watching your own shape stretch across the grass in the afternoon sun. It's just darkness, the absence of light. Nothing complicated about it. In fact, if someone asked you right now to explain what a shadow is, you'd probably laugh a little, because it feels like being asked to explain what air is. Of course you know. Everyone does. But here's the thing. Last year, physicists at a research facility in New Mexico aimed a laser at the moon's surface and calculated the speed at which a shadow could theoretically move across it. 3 billion kilometers per hour. That's faster than light. Not almost as fast, not close, faster. And nobody violated a single law of physics doing it. So let me ask you something directly. If a shadow is just the absence of light, how does an absence move faster than the thing that creates it? You can't answer that. Not yet.
But by the time this video ends, you'll be able to. And more than that, you'll never look at a shadow the same way again. Let's start with the obvious answer, the one that feels completely airtight. A shadow is simply where light isn't. You block the light source, the photons can't get through, and on the other side, darkness, a region of space that light didn't reach. It's not a thing, it's an absence, like a hole in sound when you plug your ears, like the gap between two notes in a song. That explanation is clean, elegant even, and for about 2,000 years it was good enough for everyone, including some very serious scientists. But then you run the numbers. If a shadow is just where light isn't, then a shadow has no physical properties whatsoever. No mass, no energy, no momentum, no speed limit. And that's exactly where it breaks. Point a laser at a wall. Now rotate the laser slowly. Just your wrist, a small movement. The dot of light on the wall moves. Fine. Now imagine that wall is the surface of the moon, 384,000 kilometers away. You rotate your wrist at the same speed, 3 billion kilometers per hour, 4 times the speed of light. And here's what makes your brain stall. Nothing moved that fast. Not a particle, not a wave, not information. Your wrist moved slowly, the laser moved slowly, but the shadow, the absence, crossed a continent-sized surface in a fraction of a second. So just an absence doesn't cut it anymore. Absences don't have speeds. Absences don't race across the moon. Something is happening here that the simple explanation can't touch. All right, fine. So you reach for the second answer. Maybe a shadow isn't just emptiness. Maybe it's a projection, a silhouette, a shape encoded in geometry, the precise outline of whatever object is blocking the light, transferred onto a surface, like a stamp. The object is the stamp, the light is the ink, and the shadow is the imprint left behind.
That's actually a more sophisticated answer. It accounts for the shape. It accounts for the sharpness of edges. It even sounds like something a physicist might say at a dinner party without being embarrassed. And it's wrong, too. Here's the test. Stand under a streetlight at night. Look at your shadow on the pavement. Now take one step to the left. Your shadow didn't move with you the way a physical object moves. It recalculated. Instantly. A completely new shadow formed in a completely new position, not because the old shadow traveled, but because the old one ceased to exist and a new geometric relationship was born in its place. Now crouch down. Your shadow changes shape in real time, across its entire surface simultaneously. Every point of that shadow updated at once. There is no physical object that behaves this way. A ball, when you move it, travels from point A to point B. Your shadow doesn't travel. It doesn't have a point A. It exists only as long as the exact relationship between you, the light source, and the surface holds, and the moment any variable shifts, the shadow you were looking at is simply gone. It has no fixed coordinate in space. Ask a physicist where your shadow is, and they'll tell you. It depends entirely on where you're standing when you ask. A projection has a location. A silhouette has edges you can measure. But your shadow? Your shadow has no address. So here you are. It's not just absence, because absences don't move at 4 times the speed of light. It's not a projection, because projections exist at coordinates, and your shadow doesn't. It has no mass, no energy, no location independent of the observer. You've been looking at shadows your entire life, every single day, every walk outside,
every lamp in every room, and right now, in this moment, you cannot tell me what one actually is.
Neither could most physicists until they stopped calling it a thing and started asking a completely different question. A shadow is not a thing. That's it. That's the answer. Simple, brutal, and completely invisible to you your entire life. A shadow is not an object. It is not a projection. It is not even truly an absence in the way you picture absence, like an empty chair or a missing tooth. A shadow is a relationship, a precise, dynamic, geometric relationship between a light source, a physical object, and a surface. The moment any one of those three variables changes, the shadow doesn't move, it ends, and a new one begins. You've never been looking at a thing. You've been looking at a condition. Think about what that means for a second. That shadow stretching behind you on a summer afternoon, it has never touched the ground beneath it. There is nothing there pressing against the pavement. No substance, no field, no particle that traveled from your body to the floor.
The ground in your shadow is just ground. Ordinary, unremarkable ground. Identical in every physical way to the sunlit ground beside it, except for one thing. Fewer photons are landing on it per second. That's all a shadow is. A region of statistically reduced photon density cast by an object that absorbed or scattered the photons that would have otherwise arrived there. Your shadow is not a shape of darkness. It's a shape of missing light. Photons, those massless packets of electromagnetic energy traveling at 299,792 kilometers per second, are streaming from the sun in every direction. They hit your skin. Your electrons absorb them, re-emit some, scatter others. But straight through you? Not a chance. The photons that would have continued past your body in a straight line are simply gone, absorbed into your atoms. And on the other side, a surface receives fewer of them per square centimeter than the surface beside it. Your visual cortex detects that difference in photon arrival rate. It interprets it as a shape. It calls it a shadow. You didn't see a thing. You saw a deficit. And your brain, brilliant and ancient and deeply imperfect, told you it was solid. So let's go deeper, because now that you know what a shadow is, you need to see what's actually happening, at the level where physics stops being abstract and starts being almost uncomfortably real. Every atom in your body is mostly empty space. You've heard that before, but here's what that means for light specifically. When a photon from the sun travels 150 million kilometers through vacuum and finally reaches your arm, it doesn't hit a solid wall. It hits a cloud of electrons orbiting nuclei, separated by distances that, scaled up, would be like a marble floating in the middle of a football stadium. And yet, the photon doesn't pass through you, because electrons are not passive. They are charged particles coupled to the electromagnetic field, and when a photon, which is itself an excitation of that same field, comes close enough, the electron absorbs it. The photon ceases to exist. Its energy gets transferred into the electron, which jumps to a higher energy state, then releases a new photon in a different direction, not forward, not toward the ground behind you, gone from that trajectory forever. This happens trillions of times per second across every square centimeter of your skin. The result is a cone of space behind you where photons from that light source simply never arrive, not blocked by a wall, not bounced back, absorbed and re-emitted sideways, upward, scattered into the environment, and the region directly behind you receives none of them. That cone is your shadow. Now look at the edges of it. Really look next time you're outside on a clear day. You'll notice the edge of your shadow isn't perfectly sharp. There's a soft gradient, a blurry border where the shadow fades into light. Physicists call the dark central region the umbra. The soft border around it is the penumbra. And the reason it exists tells you something profound about the sun itself. The sun is not a point, 5 degrees of arc wide in your sky. That means photons aren't coming from one direction. They're arriving from a range of angles, all slightly different. At the very edge of your shadow, some of those angles are still partially blocked by your body, others aren't. So the surface there receives some photons from the sun, just not all of them. It's partially lit, partially shadowed. That gradient you see is a map of how much of the sun's disk your body is hiding from that particular point on the ground. Your shadow is literally a diagram of the sun's angular size. And now consider color. You probably think shadows are gray, or black, or just dim. But look carefully at a shadow cast on a white surface on a clear blue sky day. The shadow isn't gray, it's faintly blue, because the shadow is lit by the sky, not the sun. Inside your shadow, direct sunlight is blocked, but diffuse light scattered by the atmosphere still reaches the surface. And that scattered light is blue, because shorter wavelengths scatter more efficiently through air, a phenomenon called Rayleigh scattering. Your shadow has a color. It's always had a color. You just weren't looking closely enough to see it. Now here's where it connects to something fundamental, something that governs not just shadows, but every interaction between light and matter in the universe. What you've been watching this whole time is electromagnetism. Photons are not separate from the electromagnetic field. They are the electromagnetic field, quantized into discrete packets. When your electrons absorb and scatter them, that's not a mechanical collision. That's the electromagnetic field interacting with itself through the medium of charged matter. Your body is a structure of charged particles, protons, electrons, and it shapes the electromagnetic field around it just by existing. Your shadow is not a gap in light, it's a scar in the electromagnetic field, a region where the field's propagation was interrupted by the geometry of charged matter. Every shadow you've ever seen, the one cast by a tree, by a building, by a cloud moving across the sun, every single one of them is a local deformation in one of the four fundamental forces of the universe. You've been walking through scars in spacetime's electromagnetic fabric your entire life and calling them shade. Now make it personal, because this isn't just happening outside, on the pavement, under the afternoon sun. It's happening inside you, right now, as you watch this. Your lungs cast shadows on your heart. Your ribs cast shadows on your spine. Every organ in your chest is surrounded by a landscape of photon deficits, regions where light from one tissue never reaches the next. When a doctor slides you into an X-ray machine, they're not photographing your bones, they're photographing your bones' shadows. The image on that film is a map of which parts of you absorbed the most photons and which parts let them through. Medical imaging is shadow photography. You are at this very moment a machine that casts shadows internally. Your body is so dense with electromagnetic interactions, so layered with absorbing, scattering, re-emitting electrons, that light navigating through you produces a completely unique shadow landscape. A shadow landscape that doctors can read like a map. They can tell them if something is wrong before you feel a single symptom. Your shadow has saved lives, possibly your own. And now step back even further, because here's what sits with me, what I think should sit with you too. Every shadow you've ever seen was never there. Not in the sense that it was an illusion, but in the deepest physical sense. There was never a substance, never a particle, never a field excitation traveling from object to surface. There was only light, and then, in a precise geometric region, slightly less of it. Your brain took that difference, that quiet statistical deficit in photon arrivals, and constructed a shape, gave it edges, gave it depth, made it feel like a presence. You've been seeing absence your whole life, and your brain has been dressing it up as something real. Every shadow in every photograph ever taken, every shadow in every painting by every artist who ever lived, Caravaggio's dramatic darks, Rembrandt's impossible depth, all of them were recording the same thing. Not darkness, the shape of where light couldn't go. He wasn't talking about ignorance. He was talking about the particular kind of aliveness that comes from standing at the edge of what you understand and looking into it without flinching. That's what you just did. You looked at something you've seen every day since childhood, and you were willing to find out you were wrong about it. That takes something. Not everyone does it. So go outside today, or tonight, or the next time light falls across a surface near you and leaves a darker shape behind. Look at it differently now. That shadow on the floor isn't dark. It's not empty.
It's the exact geometric record of every photon your body intercepted, every electromagnetic interaction your electrons won, every piece of light that hit you and never made it through. It's the shape of you, written in the language of fields and probability, pressed quietly onto the world. It's not the absence of light. It's the proof that you were there.
If this changed the way you see something you thought you understood, share it with someone who still thinks a shadow is just darkness. They deserve to have this taken from them too.